Hello, everyone. All right. So, as you can see, we will be discussing chapter 7 today. Chapter 7, which is near and dear to us as engineers. Let's see here. All right. Near and dear to us as engineers. And so, chapter 7 basically covers the fundamental dimensions and base units. What is a dimension? What is a dimension? So, the way your book reads, um, a dimension is a physical quantity, or let me actually pull that up really quickly. So a dimension is a measurable physical idea. Measurable physical idea. I think that's interesting that the book calls it a physical idea. But as it reads, it generally consists solely of a word description with no numbers dimension. Yeah, I don't know if I'd agree with that, but a dimension in more or less layman's terms, it's a form of measurement. When you dimension something, it is you measuring the something. What is the something? Well, the something could be anything. It could be how a weight of something. It could be the mass of something. It could be the height, the volume of something. It could be the temperature of something. When you think about all of these measurable things, you think about all of the entities that makes up things that make up the world, right? And so when we dimension it, dimension the temperature. Well, we say it is this, right? As far as the measurement of it. How do you measure temperature? Well, we have thermostats and we have Fahrenheit. Fahrenheit is a name. Celsius is also someone's name, right? So the founder or founding inventors or engineers of these measuring devices, they were able to name it, right? And so Fahrenheit and Celsius is what we call units, right? So when you dimension something, the something that you dimension has to have a unit, right? Mass, grams, or kilograms, or in pounds or slugs, depending on where you are. And those are units. And what is a unit? Well, a unit allows you to quantify a dimension. So the unit quantifies the dimension. And I guess from your book standpoint, that's where they're getting the number, right? The number is where you get the dimension. I mean, you get the unit. But in actuality, this is true because your number is based on how you calculated that number or measured it in some degrees. Well, when you think about Celsius, a Celsius, the number in Celsius for temperature is different than the number in Fahrenheit for temperature because of how they calculated it, right? So when you think about it or not think about it, when you are doing it, there's some standards. There are some conditions upon how you're using these units and measurements. And with that being said, it brings me to my next slide, which is the metric system. The metric system is the standard for how things are being measured according to that system. They use certain types of units. And in the metric system, or SI, right, you use millimeters, meters, you use grams, you use kilograms, you use milligrams, as far as your metric system goes. And I wish I had a yes, right? Yes, think this is right. Here we go. Use milligram meters, and the time is pretty much the same for everything. It's always seconds, minutes, hours. I don't recall there being anything different for us units when it comes to the metric system. But SI is defined as System International or metric system. SI is a standard or how do you even quantify it? How do I even quantify it? It is a measuring system used in certain parts of the world for the book says ideas or physical ideas or physical I don't even know concepts. Concepts probably not the best word either. And I'm trying to think. I'm thinking this aloud. But the measuring system governs how you measure something in call how you dimension something in a physical aspect like that governing system in the majority of the world they use SI units they use or the metric system they use that hopefully that isn't too confusing but it probably is but I'll clear it up most of you already know this and some of you may not. But then you also have the imperial system. Imperial system is another standard or governing measuring system for units. And in imperial, they use things like yards, feet, inches. For weight, they use pounds. They use miles per hour. They use feet, cubic feet, cubic inches, things such as that for volume. As opposed to kilograms, meters per kilogram, or kilograms per cubic meter, cubic meter per kilogram, right? Those cubic meter in kilogram or SI units, pounds and inches and feet or imperial units, right? And so imperial is what we use here in the United States. Obviously, when I say feet, everybody should understand it. Yards, miles, everybody should know that, oh, wow, that's what we use here in the United States for measurement. And, miles per hour, that's velocity. When you're driving your car, you're knowing how fast you're driving. That's according to what we use here in the United States, measuring your speed, how fast you're going over a certain distance. And when it comes to quantifying your time, in other words. But when you go to the SI units, they use kilometers per hour. If you're ever driving over in a different part of the world, namely Europe, you see kilometers per hour. And I believe even if you go down to Mexico, you'll see kilometers per hour if you're driving. But these are forms of measurements, things you need to know and understand. Kelvin is a relative temperature, and there's a way you can get Kelvin from Fahrenheit or Celsius by what we would say is you basically have to convert your units. You have to convert from Fahrenheit to Kelvin or from Celsius to Kelvin. So think about the learning objectives. Understand how dimensions are expressed in three main unit systems, SI, AES, and USCS. Recognize non-units that are acceptable for the use of with the SI system. All right, so comparison. So you have the SI units. SI units, like I said before, for length, mass, time, length, and notice, time is always the same. There's no variation in how we are measuring as far as SI, AS, and USCS. Give me one. And I know many of you probably wonder what is AES and USCS stand for. AES is the American Engineering System for units, and then US is United States Customary System of units, which is also imperial. You'll hear it mentioned as United States US Customary System, and then you'll hear it mentioned as the imperial system of units. And so, again, here in the US, we use typically an imperial. See, also British use slug, but we typically don't use slug. We use pound mass, which is AES, American Engineering System of Units. But in other cases, we always see slug and probably engineering problems. But the British customary system of units, they use slugs for mass, but we use pound mass, and then you have pound force. So when you always see that little M there, that's indicating on its mass, it's indicating mass. And then we use Fahrenheit, and as I mentioned before, SI, they use Celsius, and then Kelvin, and then we use Rankine as our relative temperature. And these are just other units and ways you can convert, right? So, but let's find something. So let's look at this example. So you have this example where we're going to convert the length, right? We're going to convert the length from feet to miles, feet to miles. So it says, if the Mariana Trench is one of the deepest spots in the ocean at 35,837 feet. So first we have to look at, well, what is the conversion factor from feet to miles? The conversion factor from feet to miles. And got it here, looking at my book. Here. So I have this handy, but I mean, stop sharing. And I'm going to go to share board. So there are 5,000 to 80 feet in 1 mile. All right. So the question was, if the Mariana Trench is one of the deepest spots in the ocean at 35. So we have 35, 8, 37 feet. I'm doing this with my mouse, right? And we want to convert that to miles. Now we know 1 mile is equal to, sorry, know that 1 mile is equal to 5 to 80. Man, that looks bad. Let's just know that that's an 8. Trying to do this with my mouse. Feet. Right? So what do? We have to divide this by 5280 and multiply it times 1 mile. So how do we do that? Just cross multiply. So we need 1 mile. We need 1 mile here and we need the feet to go away. So how do we do that? Well, how I was taught, we would go multiply this times 1 mile. Let's multiply the 35, 8, 3, 7 feet times 1 mile over 52, 80 feet. That way the feet cancels out. And the answer you get 35, 837 divided by 5280 is equal to approximately 6.78 miles. Do our little approximate 6.78 miles. All right, so let's do another example. Let's look at temperature. So let's see here. Fix this here. All right. Look at temperature. Temperature is always a good one. So we know T degrees C is equal to 5 ninths times T degree F minus 32. All right. So if T degree C is equal to 200, degrees C, you have 5 ninths times T degree F minus 32. What is T degree F? What is the first thing you have to do? Well, first thing you have to do is you need to cancel this guy out. How do you do that? Well, you multiply times 9/5 on both sides, right? So that cancels out over here. What you do on the right side, you also have to do on the left side. So I have to multiply 9/5 times 200 degrees C. Right. Then after that, I gotta add 32 to both sides. That cancels it over here. So plus 32 over here. And then if you leave me with T degree F is equal to what? So you know it's going to be high, right? So you're going to have 1800 divided by 5 plus 32, 392 degrees Fahrenheit. 200 degrees Celsius is equal to 392 degrees Fahrenheit. So when you look at Fahrenheit, Fahrenheit has a higher measurement than Celsius. So when you think about lower temperature, Celsius is always going to be lower. So if you have 22 degrees Celsius, that's approximately 70 plus degrees Fahrenheit. So you think at 22 degrees, oh man, that's extremely cold. Like, nah, that's really almost perfect temperature. Right? So 22 degrees multiplied by, let's see, 22 times 9 divided by 5 plus 32. It's approximately 71.6 degrees Fahrenheit. So it's really good temperatures. All right. And so, yeah, so that's converting temperatures. And there are more examples in your book that you can use for volume, length, right? So yeah, just even area. So just go through the slides. I posted them within chapter 7 on Blackboard. So just go through the examples, and you can look at a lot of your tables and just see how we convert from your SI units to your base SI units to your USCS and your AES units. So like namely things that we use like force, power, energy. Force and SI is newtons. You haven't had physics yet. But then in the, as I mentioned earlier, force in the imperial or US customary slugs or AES, it is pounds force, right? So just take a look through the slides and work some of the examples. And if you have any questions, please let me know. Thank you for listening. That's all I have.